Hi everyone, today I'm going to go over the review for activities 21 and 22. So the directions say graph each and find the domain, range, y-intercept, and the equation of the asymptote. We're also going to state if the function is increasing or decreasing below. Alright, so let's type this guy in. Let's go to the y equals screen. Oh, got a lot of equations in here. Alright, there we go. Alright, so we've got 8 parentheses 4 to the x power minus 5. All right, let's hit second graph. Let's start to plot some points. So, all right, it looks like we have an asymptote at negative 5, which makes sense because remember, this k value tells you where the asymptote is. So my asymptote is at negative 5, and this is really like negative 4.999999, negative 4.999991, and stuff like that. So that's your calculator's rounding that if you see something like that. So I'm just going to go ahead and write down the asymptote as y equals negative 5 because that is the k value. All right, now let's plot some other points. So negative 2, negative 4.5, negative 1, negative 3, 0, 3. All right, 127 is not going to fit, so I'm going to put one of these negative. Let's do negative 3, negative 4.875. All right, so there we go. Now I can see the bend a little better. So my graph is going to look like this. Okay? Alrighty. The domain of this function is negative to positive infinity. Goes on forever, going left to right. The range, my lowest y value, starts at negative 5, and it goes all the way up to positive infinity. Now remember, we use a parenthesis on the negative 5 because technically I don't have points that are included there because of the dotted line. My y-intercept is when the x value is 0. So x is 0 and y is 3. So it's 0, 3. Okay? And then as I read my graph from left to right, my function and my pencil as I trace it goes up, so the function is increasing. Okay? All right, let's look at number 2. So it looks like my function is going to be moved up 1 if we think about the transformations. So that plus 1 is actually where my asymptote is. So y equals 1. All right, and then let's go ahead and graph that. So remember, to get the E button, you hit second and the division sign. Or if you want to put the exponent in, you can hit second and the ln button, which is all the way down here. Right there. Okay? X minus 4 plus 1. So see how it kind of got moved up 1? All right, let's look here. Yeah, see again how this is 1, 1, 1, 1. That's where your asymptote is. So, oh wow, these are very, very, very tiny. I want to make sure I plotted that right. Okay, yep. Okay, so looking at my table of values, let's plot 0, 1.01. All right, and then let's plot 4, 2. What else? 5, 3.7. All right, that one's not going to fit. So let's do negative 3. It's right above there. All right, perfect. So then I connect my dots. All right. And then when the domain of this function goes from negative to positive infinity again, just because left to right goes on forever, my range, my lowest y value is positive 1. And it goes up towards positive infinity. Remember, parenthesis on the 1 because the function does not exist there. The y-intercept was at 0, 1.0183. 0.0183. Yep, okay. And then as I move from left to right, my graph goes up, so it's increasing. Real quick, let's talk about the transformations on these just for practice. This 8 would be the vertical stretch. Because this is the a value and it's greater than 1. Okay, this 4 to the x power is the base, like that's your parent function, so that's why we're not going to touch the 4. That minus 5 means down 5. If you guys look at this graph, it did move down, and it looks like it's being vertically stretched because it kind of got skinnier. Number 2 over here, this says right 4, and that means up 1. Okay, remember you got to think about the opposite sign right there. So this graph does look like it moved up 1. And the parent function here is 3 to the x power. So that would have, if you graph that, you would have seen that it's also moved to the right. Sorry, I need some water there. Okay. These formulas down below. So we got exponential growth, exponential decay, compound interest, and continuously compounded interest. Remember, we will give you guys these formulas, but you guys have to know when to use them and how to use them. So number 3 says, what is the decay factor for this equation? Remember, the decay factor is this 1 plus r or the 1 minus r term. So here it's this 0.8. Okay. What is the percentage of growth for this equation? So this is the factor. This is actually going to be a growth factor because it's greater than 1. You're doing 1 plus a number, right? So that's the growth factor. So this is really saying 1 plus 0.25. So the percentage of the growth, I got to write that as a percentage. So I'm going to move this to the right by 2 decimal places. So this would be 25%. Okay? All right, answer the following questions. You deposit $2,500 in an account that pays 6.5% annual interest. Find the balance after 5 years if the interest is compounded monthly. So those are your key words right here, compounded monthly. That means you are going to use this compound interest equation up here, okay? Now, quick review. Remember, this is the final amount, initial. R is a rate. We got to write it as like a decimal, right? N is the number of compoundings in a year, and T is your time. So because it says compounded monthly, there are 12 months in a year, okay? So that's what you need to look for there. All right, so let's see here. Find the balance after 5 years. So we don't know what that end amount is. We deposit $2,500, so that's what we start with. 1 plus, we got 6.5 annual interest, so I'm going to move this to the left too. So this is going to be 0.065 over n is 12 to the power of 12 times how many years? 5 years. Okay, so let's type that in the calculator. I'm going to move this down a little bit now. All right, so we've got 2,500, 1 plus alpha y equals, let's see, 0.065 over 12 to the power of 12 times 5. I think I typed that all in correctly. Yep. All right, so we got $3,457.04. Remember, we're dealing with money, so we only go to 2 decimal places. Okay? All right. It says, now find the balance under the same circumstances, except the interest is compounded continuously. So this is the key word here. When we're compounded continuously, that's when we use this formula. Okay? So continuously compounded. See that? So that's how we know we're using this formula here. So we don't know what the final amount is. That's what we're trying to find. The initial amount was $2,500. E, remember E is a number. Don't plug in a number there, please. And then 0.065 was our rate. And then the time was 5 years. We wanted to see what it was like after 5 years. So let's type this guy in. So 2500, second ln 0.065 times 5. So we got $3,460.08. Remember, around 2 decimal places. We're dealing with money. All right? So make sure you guys pay attention to those vocab words. All right? Now, if something, so we said that if something's monthly, compounded monthly, n would be 12, right? If it's compounded weekly, how many weeks are in a year? 52. If it's compounded quarterly, how many quarters are in a year? 4. If it's compounded semi-annually, that means it happens twice. Okay? So those are the main ones that you would see on your quiz. All right, number 5. Answer the following questions. You purchase a car for $7,000 and the value depreciates 8% annually. Write an exponential decay model for the value of the car. So exponential decay. The reason why we're doing decay is because the value of the car depreciates, meaning it's losing value, okay? So this is when we're going to use the exponential decay equation up above. So we don't know the final amount, but it starts at $7,000. 1, instead of doing a plus, we're going to do a minus because we're losing 8% annually. So take that, 1, 2, so 0.08. Oh, whoops, for the value. You can purchase a car, the value of t. Write an exponential decay model. Because we're writing a model, we're not going to plug anything in for t right now. You're just setting up the equation for the value of the car. So this should be equal to v. My fault. Okay. So there we go. Now, it says, what is the value of the car in 4 years? So now I'm just going to literally plug in 4 for t. So 7,000, parentheses, 1 minus 0.08 to the 4th. So the car depreciates to $5,014.75. All right. Any questions with that so far? Okay. All right, let's flip to the back. All right, now we are going to go over the logs. Sorry guys, I'm just checking something real quick. Okay. Yeah. All right. It says describe the transformation from the parent function to the new function. Oh, we're going over transformations real quick. Okay, so your parent function would be y equals e to the x power. So we have 1, 2, 3 extra things in there, okay? So that means we have 3 transformations going on. So this 1/2, what does that tell you? That tells us that we have a vertical shrink by 1/2. This +1 up here, that's your h value. That tells you left or right, so this would be left 1 because we got to think of the opposite sign. And this -4 is down 4 because that's your k value, and that tells you if you move up or down. Alrighty, now we're getting to the logs. Rewrite in exponential form. So Miss Wade shows the Swoop method, so I'm going to do that. And then I also teach the Bay method, so I'm going to kind of do both here. But the Swoop method, if you take this 4, start with your base, and swoop around, you would get 4 squared equals 16. Okay? Now, and like logically, think about that. 4 squared is 16. So if this doesn't like logically make sense, then you probably wrote it wrong. Okay? You're going to do the same thing here. All right? Take this 8 to the 3rd power equals the 512. Or I do the Bay method. So you guys know how to spell Bay, B-A-E. All right, that's like the slang term for your boo or whatever. But so this is going to be the base of your exponential form. The exponent is the e, so 3, equals the answer, a, 512. All right, so either method is fine. They both get you to the right answer, so it really does not matter. Okay, you guys can decide what you want to do here. I'll do both. So 5, swoop it around. So 5 to the negative second equals 1 over 25. Remember, if you have a negative exponent, that really just means 1 over 5 squared, which is 1 over 25, because 5 squared is 25. Okay? If you did the B-A-E, the base is 5, the exponent is negative 2, the answer is 1 over 25. Okay? See? Works for both. All right, now rewrite in logarithmic form. So again, you can do the swoop method if you want. All right, so you would have log base 10 of 100 equals 2. All right. If you wanted to do the Bay method, you could think about this is your base, this is your exponent, and this is your answer. So here's my base. Well, now it has to spell Bay, right? So there's the base, there's the answer, and there's the exponent, or there's the E. So B was 10, A was 100, E was 2. So again, it does not matter which method you do as long as you get there. All right, over here, here's my base, here's my exponent, here's my answer. So when I write out my logarithm, it needs to spell Bay, right? So my base was 10, or B is 10, A is Y, equals the exponent is X. Okay? If you want to do the swoop, circle the 10, swoop back around. So 10, Y, X. All right, so let's evaluate these, okay? So remember, if there's not a base right here, it is 10. So if it's hidden, it's a 10. You got to remember that. All right, and we're going to set these equal to X since we're evaluating them. So this is saying 10 to the X power, so depending on if you use the Bay or the swoop method, okay, 10 to the X power equals 10 to the 5th. Now, because these have the same bases, we can set the exponents equal to each other. So X is 5. Okay? All right, number 13. Again, there's no base here, but it's a 10. All right? If it's if there's nothing there, it's a 10. It's a common log. So we set this equal to X. So this would be 10 to the X power equals 1 over 100,000. Okay? Use the Bay or the swoop method to set that up. Now, we got to think. This 10 ends up in the denominator. So I know X is going to equal a negative number. Kind of like what we did up here with that negative exponent. Okay? So then from here, I just need to count how many zeros I basically have. I have 1, 2, 3, 4, 5. All right? And you guys can double check that in your calculator. You could do 10 to the negative 5th, math, fraction. Oh, it won't give you the fraction. That's weird. Well, you can count how many zeros there are, and that helps you out there. Okay? All right, number 14. We're evaluating, so set it equal to X. Again, use the Bay or the swoop method. So we get 5 to the X equals 125. And we got to ask ourselves, how many times do we need to multiply 5 by itself to equal 125? Well, we know 5 squared is 25, so that's not going to be it. Let's do 5 to the 3rd. Oh, look, there we go. Oh, sorry, my calculator wasn't in there. See, 5 squared is 25, so that's not the answer. 5 to the 3rd is 125, so X is 3. Okay? All right, last couple problems here. Rewrite as a single log and evaluate. So we are going to use your your logarithmic properties. Sorry, I need more water. Okay. So here we go. Remember, if you have a number out in front, you can move that to the exponent. So this is log 3 squared plus log 1/9. Okay, let's simplify this. 3 squared is 9, right? So I have log of 9 plus log of 1/9. Now, when you are adding logs with same base, we can multiply these values, okay? So that is going to give us log of 9 times 1/9, which equals log of 1, all right? So really we are evaluating log of 1 equals x, so we need to figure that out. Remember, since there's not a base here, it's just a 10, so 10 to what power equals 1? Use the Bay or the Swoop method to set that up, like we did up top, all right? So anything to what power always equals 1? 0. Good job. Okay? You guys do need to know that. All right, number 16. All right, we do have a number out in front again, so let's move that guy. So log of 80 minus log of 2 to the third, which gives us log of 80 minus log of, remember this is not 2 times 3, be careful there. That means 2 times 2 times 2. If you don't know what it is, type it in your calculator. It's 8. And because we're subtracting, we can divide these logs because they have the same base. Or not the logs, but the numbers inside the log. So it's log 80 over 8. Oh, you can't see that. Which gives us log of 10. Which, if I set that equal to x, like we did on problems 12 through 14, how I'm going to solve it, remember, if there's not a base there, just common log of 10. Use the Bay or the Swoop method to set it up. So 10 to what power equals 1? Or equals 10. I said the answer 1. 10 to the first power is just 1, or is just 10. Okay? All right, last type of problem we're doing is the expansion of the property. So up above, we wrote these as single logs right here and here. But now we need to expand them to look like this. So we're going backwards, okay? So first, if you are multiplying, do you guys see how this x squared and this y are being multiplied by each other? We need to separate that out. If they're being multiplied, we really are going to be adding. So I'm going to write log of x squared plus log of y. You can't forget to write the log in front of that y, okay? Then, because I have an exponent up here, remember how we took this number out in front and moved it to the exponent? Well, because we're working backwards, we're going to move it back out in front. So we're going to move this guy out here. So 2 log of x plus log of y. All right? And this 2 does not go in front of the y term because this y term is not being squared. So just be very careful with that. See which variable has the exponent on it. All right? So just be very, very careful about that. All right, and this last problem. So it looks like we're dividing this log. So remember the opposite of division. In the log properties, we're going to subtract these. So we're going to do log of xy minus log of z. All right. Now, notice though, right here, we're multiplying x and y together. So that really means I can add them. So log of x plus log of y. And then I still have minus log of z. That's really all we can do. There's no extra little things. There's no exponents to deal with. All right, guys, that's it. Let me know if you have any questions. See ya.